She knows me too well. So my name is Salim. I like the picture you see on the board, and I love the conversations that we've been having about STEAM clubs, because in that picture we have parents, we have kids, and we have university students doing engineering, all working together to build stuff. Yeah. So my name is Salim. I come from Kenya. I work for an organization called iHub. It's a hybrid hub. So we have incubation, acceleration, software development, research, and other programs for entrepreneurs and innovators to grow across the country and the East African region. Because some of our programs are region-based. I'm here this morning to talk to you about something I'm passionate about, which is STEAM clubs, which is kids working with technology. In my experience, in my work at iHub, we're always saying there's a shortage, but we're not finding the problem. And the problem is that in the curriculums in the primary schools and the high schools, not a lot is being done for ICT and engineering to get kids more excited at that age before the university. So our program is called the Kids Hacker Camps, and when we started it, it was because many parents, when you're taking your kids for after-school classes, you're thinking piano classes, soccer, any kind of instruments. But there's very few parents who take the kids for the science activities and for ICT clubs. So when we started in 2013, there was a shortage of those, and we wanted to create those. So we've gone through many branding changes. So depending on what you search for on the internet, you could either find it as the KHC, or the Waza Experience, or the Little Bits, which I've been doing this year, or the coding class, or the art class. And this is because I've been using different electronics or different softwares to run the programs, hence the names. But the program is called iHub Kids Hacker Camps. We developed the curriculum in-house, and well, this stat is a little bit old. I think over 300 kids have gone through the program. Only the number seems small because we do it. We need only small numbers of kids when we run the class for it to be more hands-on and more effective. Sorry. Anyway, I can continue. The next slide. Yeah. Thank you. The next one, please. Oh, great. So what is the program? We teach kids how to build anything with electronics. We also teach them how to program. And a lot of the work is, the electronics take like 10-15 minutes to assemble. The artwork is the hard part. If I tell you to build like a remote controlled car right now, you'd think about it, right? You draw it on a piece of paper, which is, and then they'll tell you to make it. But the electronics needed for a remote control car is just some power, maybe a 9-volt battery, a wire, a motor to spin the front wheel so that it can pull the rest of the car. And the rest is the artwork, which is, and a remote control trigger, a small electronic, so that if I use my remote, it will work. The rest is how you build the body of the car, how you build the shape, what you use for the materials. Do you use the bottle tops, or do you use the cardboard or plastic? So the artwork is the hard part. So we're teaching kids how to explore curiosity, their creativity, their critical thinking skills, their collaboration, the 5 C's more or less. So that then they can be more curious about engineering, they can be more curious about computers and STEM-related subjects. So the picture on the left is a children's home. They were making a home alarm system that day. I don't know why, but for some reason they like making the mask more than the actual home alarm system, because then we play the game Catch the Thief. On the right is a private school called Dutch School, where the kids were making a solar system. And it's really simple. The electronics were really just a little light and a battery. And the rest was the artwork, and we printed a solar star chart from the internet, and they attached it to their cones. And then you make the room dark, and they can cast the solar system in their roof or on a white area. So sometimes some of these activities are really simple. It's just a matter of creating opportunities for the kids to try. So Benjamin Franklin said, "Tell me and I forget," like I'm doing now. Teach me and I remember. Maybe you'll remember a little bit of what I'm saying. But if I asked you to make the car with me right now, there's a high chance that you will learn and not forget. and that's really more of the motto of what we do with our programs. I'm a big fan of encouraging kids to interact with technology. Sometimes you have old electronics in your homes that are broken and you don't need them anymore. Encourage them to break them and see what's inside. And so encourage kids to tinker, to explore that curiosity, to see what's inside, especially if we want more girls or more kids working with engineering and technology. There's got to be a way we encourage them. For this presentation, I'm focusing more on the electronics class, but with the programming class, with different programs, you can teach kids how to make simple games and then advance to the more complex things. And the reason for gaming is a little bit easier to start with. So if you teach a kid how to make a game that can count many times, and then they'll be like, oh, what happens if I decide to insert objects? Or what happens if I decide to do this? And that way of thinking gets them more excited and curious to explore. Running kids programs is expensive, and so we want to keep the costs as low as we can. We also noticed in Kenya that a lot of the engineering students, especially in the first year, second year, don't interact with electronics until third year, which is very sad, and I don't know how it is for other countries across Africa. And so we work with engineering students to be the facilitators of the class. My kids are aged 6 to 15 years, and so working with somebody who's maybe like in their early 20s or has just finished high school, they're more close to the age gap, and they can relate and maybe use analogies that are easy to relate when running the classes. I think the hardest part for me is I always tell my trainers, don't do it for the child, let them do it. Put your hands at your back if you must, so that then the child keeps trying, and then when they finish and they make whatever project they make, they'll be able to explain it to their parents. And so train trainers, and to keep your costs low, you can work with university students. The beauty of this is they will be able to get ideas for projects they can work with in their schools for their fourth year or fifth year projects. So my program has simple projects, and some of them are listed on the board. We teach them how to make a remote control car, or a home alarm system, or a lift or crane. The idea is we start with very simple technology. So last year we were using the little bits, which are magnetic electronics, color-coded. In previous years we've been using the Arduino, which is a microcontroller, a small computer the size of my hand, costs about $35, or the Raspberry Pi. And next year I'm moving into e-waste, and the reason for this is when you run such a program, you always run into 3 problems. It's the saddest thing when they've made their project and then you have to dismantle it because you need the electronics for something else. So we're looking into e-waste and how we can recycle it. So we've partnered with an organization that recycles e-waste so that we can harvest the motors, the fans, and some of the LEDs that are part of regular electronics at home, like your radio, your iron, or your old toys. And the curriculum keeps evolving to incorporate new things. It's covering concepts of basic programming, assembly, design, and IoT. And topics we've explored so far are around motion, lights, sound, security, and the cloud. So the picture on the right is we were making imitation of the London Bridge. Imitation of the London Bridge, where you control it from the computer. And finally, I know I can't cover everything in this small presentation, so talk to me if you're interested in running a STEAM club activity for after school with your kids or with the girls in your communities, and I'll be happy to share resources.